Hi, this is lesson number 20, problems. In this video, we're going to go over acid and base calculations. And we're going to start off by looking at a strong base in water, NaOH. And we should know NaOH is a strong base, one, because it says it's a strong base, but also this one we should memorize. Okay, so NaOH is a base. And so what does it do? It's going to go ahead and it's going to form Na plus and OH minus. Now, it's strong, which means all of it dissociates. So what that means, if I start off with 0.2 molar NaOH, I'm going to get 0.2 molar Na plus and 0.2 molar OH minus, right? It fully dissociates. Now that I know that it's 0.2 molar OH minus, I can go ahead and I can try to calculate pH based on this. But I can't go directly from OH minus to pH. What I have to do is I need to calculate H plus first. And then I can find OH minus, or pH. All right, so if it's 0.2 molar OH minus, I can use the fact that Kw equals H plus times OH minus. And therefore, H plus equals Kw over OH minus. So that's 1 times 10 to the minus 14, that's the value for Kw, over 0.2 molar. This is going to get me my H plus. That's going to be 5 times 10 to the minus 14. I now can use this to say pH equals negative log of 5 times 10 to the minus 14. This is going to get me negative. And this value is going to be negative because it's negative here. So it's going to get me negative 13.3. And so that's going to get me a pH of 13.3. Does this make sense? It makes sense because I have a base, I'm putting in water, it makes sense that I get something that's going to have a basic pH. And if we go ahead and we compare it to what we did earlier, we got 13.3. In class, we had 0.04 molar NaOH, and that actually got us, that got us 12.6 for a pH, right? So I go ahead, I calculate H plus, then I use pH equals negative log H plus to get pH, right? Earlier in class, I had 0.04 molar NaOH, and that got me 12.6. Well, it makes sense that if I have a higher concentration of base, what do I get? I get something that is more basic. All right, now let's move on to problem 20b. Now 20a was dealing with a strong base. Okay? Strong base, we know it dissociates fully. 20b deals with a weak acid. Okay? We know that HF is a weak acid because it has a very small Ka. Right? Notice our Ka is 3.5 times 10 to the minus 4. Right? So if HF is an acid, because it has Ka, and it's a weak acid, because it has a small Ka, then I can go ahead and I can say HF is going to go ahead and do what acids do, produce H plus. And I'm going to be left with F minus. And it's weak, so I have this equilibrium. And so my Ka here is 3.5 times 10 to the minus 4. It's small, right? That means I'm going to have a lot of HF and just a tiny bit of it forming H plus and F minus. All right, so now that we have a reaction, we can go ahead and we can set up our ice table. What were we told? We start off with 2 molar HF. We assume we have no H plus and F minus. Now, it should be giveaway as soon as I have 0 for products, that means my Q is 0 because my Q is H plus times F minus over HF. So if I have zeros on the top, that's going to get me a Q of 0. All right, so if my Q is 0, and my K is 3.5 times 10 to the minus 4, this is a small number, but it's bigger than Q, so it's going to shift towards the right. I also know it's going to shift towards the right because if I have 0, I can't get smaller than that. I have to get bigger than that. So that's going to be plus x, minus x. It's going to give me 2 minus x, and x. And now I go ahead and I plug these in to my equation for k. I can do that now for k because I'm at equilibrium. So this is going to be x squared over 2 minus x equals 3.5 times 10 to the minus 4. All right, so now I can go ahead and I can use this. Now, can I use the fact that x is small? Yes, because both of these are less than 0.01. Okay, so that means I can just say that x squared over 2 equals 3.5 times 10 to the minus 4. I'm going to have to go back and check this assumption later. I'll do it at the very end, but this is key. All right, so let's go ahead and say x squared equals 7 times 10 to the minus 4. I want to take the square root of that. That's going to get me x. So if I have 7 e to the 4 minus, I take the square root of it. That's going to get me 2.6 times 10 to the minus 2. That's going to be my value for x. Okay? We're going to come back and we're going to check our assumption and we're going to check our k. But let's go ahead and actually answer the question. Okay? It asks for the pH. So once I know x, I can go ahead and I can plug it in here. I have 2 minus 2.6 times 10 to the minus 2. This is going to get me 1.97. Okay. All right, so I care about pH, so I'm going to use this H plus to figure it out. So I'm going to take pH equals negative log of H plus. That's negative log of 2.6 times 10 to the minus 2. I know before I even put this in the calculator, I'm going to get something around 2, right? Because this negative 2, the log of that will get me something around negative 2. And then I take the negative of that, so it'll get me something around 2. Okay? 2.6 e to the negative 2. Take the log of that. I get 1.59. That's my pH. Okay? Does this make sense? Yes, because I put an acid in there, so I better get a acidic pH. Remember, less than 7. All right, let's go ahead and answer the second part of this question, which asks for the percent ionization. All right, so the percent ionization, what I go ahead and do it, I use my H plus at equilibrium. That's 2.6 times 10 to the minus 2 over the amount of acid I had at the very beginning. And then I multiply by 100%. Okay. So this is going to get me my percent ionization. And I get 1.3%. That makes sense because at the very beginning I said this is a weak acid. And what do weak acids do? They only ionize a very small amount. In this case, 1.3%. All right, so that's it for this problem. We'll show it on the screen in a little bit, but let's just go back to what we did for equilibrium and let's check our work, right? Remember, we said we can check our work by doing K, and I can basically plug these things in. So that'll be 2.6 times 10 to the minus 2 times 2.6 times 10 to the minus 2 over 1.97. And what do I get as an answer? I get 3.43 times 10 to the negative 4. That's pretty close to what I started with, right? Not exactly, because I made that assumption, but pretty close, okay? And now, let's do the last thing we want to do, which is check our work, right? We assumed that 2 minus x equals 2. In reality, it equals 1.97. So we need to check this. So I'm going to say percent off equals 2 minus 1.97 over the actual value times 100%. Okay? We always want to make it positive, so I can just put that absolute value there. Or I just set it up so that 2 minus 1.97 will give me a positive. All right, 2 minus 1.97 divided by 1.97, and then multiply by 100%. I get 1.5%. Okay, so that means it checks out. Let's go ahead and show this on the screen. All right, so the first thing we did was we set up an ICE table where we put in our values that initially found our Q, determined that it shifted towards the right, found our changes, plugged those in for equilibrium, and then found our K. We then used that to solve for X. In this case, X equaled my H plus, and so I could just plug that in to find my pH. And then what did I do? I used my H plus at equilibrium over my initial pH, or HA, my acid, times 100%, and that gave me my percent ionization. All right, bye-bye.